Hello everyone, I am Rohitadi Mandadi. I am going to explain about OIBSIP Infobed Data Analytics Level 1 Task 2, that is Customer Segmentation. Customer segmentation is a process of dividing a customer base into distinct groups based on shared characteristics such as demographics, behavior interest, purchasing habits, and preferences. This enables business to tailor their marketing strategies, improve customer experience, and optimizes the product offering to the specific customer needs. In the description, you just observe the aim of the data analytics project is to perform the customer segmentation analysis for an e-commerce company by analyzing customer behavior and purchase patterns. The goal is to group customers into distinct segments. This segmentation can inform targeted marketing strategies, improve customer satisfaction, and enhance overall business strategies. So let us jump into the project here. First, we're going to import the libraries, that is pandas, numpy, matplotlib, and seaborn. Numpy is for displaying the dimensional array in the dataset, and we're going to import the dataset by using pandas. Matplotlib and seaborn is for visualizing the dataset. Next, we're going to mount the Google Drive, and next we can import the dataset here. And next we're going to display the dataset by adding first 5 rows in the dataset. Next, we're going to display the information of the dataset. In the information, you can just observe total 39 columns are there in this dataset. And next, we're going to describe the dataset by adding some count, mean, and standard deviation here, and including minimum, maximum, and these are the percentages which was included in this dataset. Next, in the shape of the dataset, you can just observe it is having 2205 row entries here and included 39 columns. Next, we're going to display the correlation matrix in this dataset here. Next, we can define the columns. You can see it is having 39 columns are there. Next, in 39 columns, we can check the data that is there any null values are there or not, or is there any missing values are there. As you can see that there is no null values and missing values are there in this dataset, so it's good to go. Next, we're going to check the column types. In the column types, you can just observe the first column is the income column, which is in float data type, whereas the others were in the integer data types. Next, we're going to assessing the unique values by defining the n unique values in this dataset. You can just see the first column is the income is having a high unique values in this dataset. Next, we can drop the Z cost and Z review columns here. And when you can just observe that in Z cost contract column and Z revenue column is having only one unique value. So we cannot drop those lowest unique values are there. We cannot drop them for both the columns having the same value. Next, let us visualize the data by using with box plots, histograms, pie charts, scatter plots, correlation matrix, and bind value correlations. First, we're going to visualize the data, that is the box plot. This is a simple box plot which was visualized here. And I added some description here. That is the median means the middle value in this dataset. I will explain here. This is the box plot. In the box plot, the middle value of the dataset is the median. The middle line of the box is the median, whereas the first quartile that shows the lower half of the data and third quartile is for upper half of the data. When you just go to scroll down here, you can just observe that the middle value is the median, and whereas the lower whisker is the pink dotted lines is showing on the down is the lower whisker, and Q1 is for first quartile. Q1 is for first quartile, which is showing on downwards, and whereas the Q3 is for upper quartile, which is showing on upside, a box plot on upside, and whereas this pink dot on the top, you can just see here in the mouse cursor I'm showing here is the upper whisker, and it is showing some circles here, small circles is showing. These are the outliers. For more details, I will tell you. The first quartile, which is having a 25th percentile, is the median of the lower half of the data. That means lower box, the lower line of the box plot here the lower line of the blocks in the green color is the first quartile, and whereas the upper half of this box plot we will showing is the third quartile. Whereas the interquartile, you can just observe IQR, that is the range between the third quartile and the first quartile by subtracting the third quartile to first quartile. Then coming to the whiskers, I told you the lower whiskers and the upper whiskers, which is shown in the pink dots here, which are in the box plot here. Next, that is for extending the smallest and largest values within the interquartile range by multiplying with 1.5. I have shown you the circles where that's where the outliers, which points outside the whiskers shows as the individual dots. Next, we're gonna scroll down. We already observed the data that it is having outliers. So for outliers, I told you that the box plot which has spotted some few outliers in the MMT total. Let's take a closer for understanding the outliers in box plot. So what we're gonna do means, we have in MNT total column, we have taken the first quartile of the dataset, which is on 0.25, and MNT total column, we can select the third quartile, which is 0.75. For interquartile, we can subtract the third quartile to first quartile, and we can have the lower bound, that is the first quartile, for subtracting the interquartile by multiplying 1.5, for subtracting the first quartile. For upper bound, third quartile plus 1.5 into interquartile range. So then next line is the outliers. For detecting the outliers, that MNT total data which is less than lower bound, for MNT total which is greater than upper bound, and it shows the values like here. Whereas in 1159th call 9th row, 1467 row, and 1547 rows, that including 39 columns, it shows the values like this. This is the final result. Next, we're going to remove the outliers by describing the data, that is MNT total which is less than lower bound and MNT total which is greater than upper bound, and we can describe the data here. And next we're going to remove the outliers here. Next is histogram for box plot for income, guys. This is the box plot for income, and in this income box plot there's no outliers. Next, we're gonna jump into the histogram for income. For histogram, that X is the income, and total 30 bins are there in this data set here, and the palette is Verdes, and we just added some color in this box plot, in this histogram plot here, and I added those line thread here. This is the skewness and kurtosis in the histogram for income. And next I added the histogram for age also. First is the income I added here, and next is the histogram for ages. And we added, and next for Y label I added the frequency also, that is the frequency of the histogram of the age, which we included the skewness and the kurtosis. So what is the skewness? Skewness measures asymmetry of the data distribution, that tells whether the data is skewed to the left, that is the negative skew, or right is the positive skew. So what is the positive skew and negative skew? See, positive skew means tail is longer on the right side, which is mean is greater than median greater than mode. For negative skew, tail is longer on the left side, which is mean less than median less than mode. And for zero skews, both are these mean median mode are equal, which is like a normal distribution. For kurtosis, you can just see leptokurtic, which is kurtosis which is less than 3, sorry, greater than 3, then heavy tail more outliers, whereas the mesocortic, the kurtosis which is the 3, this is the normal distribution, whereas the platycortic, which is cortex, which is less than 3, that light tails fewer extreme values. When you can just observe the skewness, which is having 0.091, and whereas the kurtosis, which is minus 0.79. So it's good to go, guys. Next is the correlation matrix. In the 39 columns I already displayed in the dataset, that 39 columns we can split into demographics like this. For demographics, children, martial, MNT, communication, campaigns, source of purchases, and educations here. For displaying the correlation matrix. See, correlation matrix will be crowded if we use any columns at data pair. We can group those columns into and explore the correlation between columns in each group. That column MT total will focus on column MNT total to understand how we can segment the customers who buy the most overall. We can run the similar analysis for every type of the product, and this is the correlation matrix. Next, we're gonna have biserial correlation for binary values, but we can use personal correlation for MNT total for age and income for trying to understand the relationship between a continuous variables for MNT total and binary values like Marshall status. That we can use the point biserial correlation and is used to measure the strength and direction of the linear relationship between the binary values and continuous value. And we can just observe that there is no strong relationship between the MNT total and various education levels and different Marshall status. Some features engineering may be required during the modeling process. Next, we're gonna jump into the feature engineering. In the feature engineering, you can just observe we're gonna take the Marshall feature here. We can create a plot here, that is the bar plot for MNT total for Marshall status. Next, we can add the new feature, that is the in relationship. In relationship, we can select the married and together and data, which is the in relationship, and we can just display the values here. Next, we're gonna have the k-means clustering. So in the machine learning model, we can have a k-means clustering here first. K-means clustering is an unsupervised machine learning algorithm to cluster data based on similarity. K-means clustering using work well in practices and scale well in the large dataset. When you just jump into the description, you can just observe that we can have to utilize the clustering algorithms by using k-means to segment the customers based on behavior and purchase patterns. So let's jump into the project here. That k-means clustering, that what we are going to do means we can import the standard scalar and we can cluster the income, MNT total and in relation. So we're gonna first describe the data here, and we're gonna jump into the principal component analysis for PC1 and PC2. So principal component analysis is a technique of dimensionality reduction. Okay. So next, for elbow method here is a technical used to determine the optimal number of clusters for k-means clustering algorithm. So it is show like a elbow graph here, and this is the line plot of the number of clusters, and Y label is for inertia. Okay. Next one is the Sellout score analysis. Sellout score is a matrices that used to access the quality of clustering. In the elbow method, we can suggest 4 or 5 clusters. Let us use the Sellout score. A high Sellout score indicates the clusters as well as separated with lower score suggests the clusters may overlap and poor defined. And it shows the graph here, including the Sellout score on the X label, and whereas the Y labels is for number of the clusters. The highest Sellout score is for floor clusters, and whereas the elbow is showing for 4 to 5 clusters. Now, so we're gonna explore the clusters, guys. By visualizing the clusters, mean consumption of different product types by cluster size, income by cluster in relationship feature by clusters. First, we're gonna visualize the clusters, which is having 4 types of clusters here. So you can just see, I will just adjust the figure size here, and we're gonna use the scatter plot for PC1 and PC2, which is data was scaled, and it should be clustered. And I added a color of this plot, of this scatter plot here, that is cool warm. And we're gonna add the title, that is the cluster data visualization. X label should be have the first component, that is PC1 here. X label is the first principal component 1, and whereas the Y label is for principal component 2. And we can add a legend, which is how many clusters you want to visualize in this data set. Okay. Next, in cluster data is added the scalar cluster here. I'm going to group these clusters for adding the mean. So you can just observe in 4 clusters we have added the mean for income, MNT total and in relationship. Next, we're gonna have the mean consumption for different product type by clusters. For that, we're gonna have this histogram here. We can just observe totally 8 products are there. For 8 products, that Each and every 4 clusters were visualized by using this histogram here. You can just observe here that mean melted data, it is should be clustered and it should include the products here, and then consumption and value name should be consumed. Okay, for bar plot, X should be clustered and Y should be consumption, and U is the 8 products are there. Melted data and palette should be color of this visualized histograms is the code form, and we can include the title here. X label is the cluster, and as the Y label shows product consumption. Okay, and we can rotate into 0 degrees. Okay, next this is the visualize the histogram including 4 clusters here. Next we're gonna include the cluster size here. By including cluster size, we're gonna group the cluster data and MNT total by counting the index of this data here. We're gonna adjust the figure size here. X is the cluster, X axis is for cluster, Y axis for MNT total, and the data should be the cluster sizes. And we're gonna include the colors of in this bar graph here. Then we're gonna add a title for cluster sizes, and that's it. This is it shows the bar graph here. Next, we're going to include the length of the data here, and the cluster size should be in cluster size. We're including the share percentage here. Okay, so we're going to cluster those 4. We're going to have 4 clusters here, including MNT total and share. For that, you can just observe a simple scatter plot is added here. Okay, for MNT total versus share, where you can see MNT total for x-axis and y-axis is for shares. Okay, this is the income of the cluster. Coming to the next is the box plot. For box plot, you can just observe that this is the income of the clusters, whereas the clusters is the x label and y-axis is for income, and it creates 4 types of box plot. But you can just see the third box plot that includes the outliers. Okay. Next, we're gonna jump into the scatter plot for income. It is having flow clusters. I already explained to you. For this one, I adjust the figure size here. X label is for income, whereas Y label for MNT total, and all data should be required, and the clusters should be required here. And whereas you can adjust some colors in this dataset, I adjust the color, variety of color, that is the cool warm here, and included the title, that is the income of the cluster. X label is for income, Y label is for MNT total, and I included this scatter plot here. Next, we're going to create a machine learning model for DBSCAN, that is density based spatial clustering of applications, including noise. That in this data is having some noise values are there. For that, we're going to just write the code by using sklearn. For clustering, we can import the DBSCAN. For neighbors, we can import the nearest neighbors. For matrices, we can import the silhouette score, mean square error, R2 score, and accuracy score. And we can add some features, that is income, kid home, 10 house, recency, MNT wines, MNT fruits, MNT meat product, fish, sweet, gold, MNT total, MNT regular products, and accepted CMP. Overall total 13 columns. We have 13 columns. I was selected as a relevant features for clustering. Next, we can standardize the features, and we can find the optimal epsilon by using k-distance graph here. So this is the k-distance graph for elbow method for DBSCAN at epsilon. Next, we're going to apply the DBSCAN for choosing the parameters. So after applying the DBSCAN for choosing the parameters, let's come to the silhouette score for clustering, guys. For silhouette score, silhouette score can be computed only if the cluster found, and the score it is having 0.160. This and so on, 0.160 and so on. Next, we're going to include types of errors for model performance. First is the mean square error. For in mean square error, which is coming 0.13 here, and I added some description that when it is in 0.13, which is less than 0.5, it is good. That data points are tightly clustered around the centers. Okay. For real mean square errors, you can just observe that the root mean square error is having 0.34. For 0.34 mean should be 0 and standard deviation is 1. which is less than 0 point indicates well clustered point, means data points are close to the cluster structure, which is 0.34, and it is not in 0.5. Okay, next we can include the k distance plot for db scan, the elbow method for finding the optimal k in k means clustering. Okay, we can include this graph here for k distance plot for db scan. After that, we're gonna jump into this graph here. In this graph, we're gonna have the elbow method for optimal k, whereas the x label is for number of clusters and y is for within the cluster sum of the squares. What are the sum of the squares that we can include in this y label? Okay, and it shows the graph here. Next, we can have the minimum samples using this log rule. In density based partial clustering of application noise, the minimum sample parameters which can determines the minimum number of points required for density range. Okay, so these are the different types of Silhouette scores for minimum samples which is chosen here. And next, we can find the best minimum samples for db scan using Silhouette score. So which is close to is well clustered, whereas the minimum samples which are around 0, which is overlapped, means the clusters which are overlapped. And for negative values for minimum samples, and we can just finalize that it is a poor clustering. Which is close to 1 means it is well clustered. Okay. Next, we're going to check the percentage of noise points. For checking the percentage of noise points, the number of noises by total points into 100. After calculating that, then we can have the noise percentage, that is 0.27. db scan marks some points as a noise -1 labels if they don't belong to any density region. Then if more than 30% points are noise, then db scan it will be too strict. Now it is in 0.27% of noise, that means it is the db scan will be too strict, whereas the db scan, see, in 0.27% of noise here, whereas it reaches to 0.30%, it will be too strict for db scan. Okay, so next I'm going to show you the effect of epsilons on noise percentage in db scan here, whereas epsilon which was displayed in x label and y label is for noise percentage. Okay, next we're going to compare the db scan with k means with Python. Okay, for k means Silhouette score is showing 0.5, whereas you can just see that 0.5 to 0.7, which is good clusters and it is well defined, but might have some overlaps here. Because of noise percentage, it was some overlapped. When it is reached to 0.7, when we can say that it is external clusters and well separated and compacted, which is less than 0.10%, then we can say that poor, no meaningful clusters, k means are not to be best choice. Okay, so next we can optimize the k using Silhouette method. We can have the graph here again. Number of clusters in the x label and y label is for Silhouette score. Next, we're going to standardize the data by using k-mean performance. Poorly on unscaled data, we can use standard scalar or min-max scalar here. By using principal component analysis to reduce the dimensions, high dimensions data can be make the clusters harder. By trying PCA, we can just observe that in the new Silhouette score for after principal component analysis, it is having 0.61 and so on. Is there any suggestions? You are welcome, guys. So that's it, guys. This is all about the customer segmentation, that is a level 1 task 2. Is there any suggestions? You are welcome. Thank you.